Hello and welcome to your daily dose of geometry. Today we're going to be talking about congruent triangles and how to prove that two triangles are congruent using these shortcuts called postulates. Now a postulate is a statement that is accepted as true without proof. Oh darn, didn't mean to do that. And the reason we can accept it as true is because we know through things that I've shown you in class that if just these three pieces of the triangle are congruent, then all 6 pieces must be congruent. So, connecting this to the last unit that we were in, we have got reflections, rotations, and translations, which all change the location of a shape, but not the shape, size, or like how it's shaped. So a reflection would be, that game controller is reflected over the line, but it's still the same shape and size. A rotation is rotated 90 degrees clockwise, but it is the same shape and the same size. Translation, it would be shifted to the right, but that image is the same shape and the same size. Now dilations, remember, is an enlargement or a reduction, so it's not the same shape, it is the same shape, not the same size, therefore it's not congruent. So remember that CPCTC tells us that if the triangles are congruent, then AB equals DE, AB equals DE, and angle A equals angle D, and BC equals EF and angle B is congruent to angle E. And for the last angle and the last side, we know that side CA is congruent to side FD, and angle C is congruent to angle F. So CPCTC tells us that if the triangles are congruent, then all of their parts are congruent. All of their angles and all of their sides are also congruent. But what if we don't know that they're congruent already? What if it is asking us, are these two triangles congruent? Well, we would have to go back and we would have to go through all 3 sides and all 3 angles to show that they are congruent. But that's too long. 6 pieces of information, proving each time, too long. So there are shortcuts where you only have to show 3 pieces of information. And that's what we're going to learn about today. So remember that these postulates, and then there's another one, HL. These 5 shortcuts or ways can be used for any triangle except for HL, which obviously can only be used on a right triangle because HL, hypotenuse, leg. So hypotenuse and one of either that leg or that leg. Both of these are legs, and you'll see. So shortcut number 1, side, side, side. This one says if all of the sides of 2 triangles are congruent, then the entire 2 triangles are congruent. So all the sides. So side, side, side says if AB equals DE, and BC equals EF, and CA equals FD. Then triangle ABC is congruent to triangle DEF. Another example, we've got a side, a side, a side, a side, a side, a side, and they've got 1, 2, and 3 tick marks. And if we rotate this 90 degrees, more than 90 degrees, that way it would line up and lay right on top of that first triangle. Another one. Ooh, now this is good information. So you should always look out for reflexive sides. A reflexive side is any side that is shared by both of the triangles. It is always equal to itself, right? Because this length is always going to be this length. So we can say that this is equal to this. So it has side, side, side. This one goes with this one goes with this one, and then this one goes with itself. Next, side, side, side. All right, shortcut number 2. What if you have a side and then an angle and then a side? And yes, as with all things congruent triangles, the order does matter. So it says if two sides and the included angle, aka the angle squished between the two sides of the two triangles are congruent, then the entire two triangles are congruent. What it looks like is this. AB, if AB equals DE and angle B is congruent to angle E and line BC or side BC is congruent to side EF, then the entire triangles are congruent. And again, the big thing here to remember is that side, the angle must be squished in between the two sides. So what does that look like in practice? Well, here's one. Ooh, here's another good thing. Okay, we can imply this angle and this angle. We can imply that those two angles are equal. Well, how do we know? What kind of angles are they? Well, they're vertical angles. So this is a big important thing. Just like on the previous slide, we had that reflexive side that had that will always be equal to each other. These vertical angles will always be equal to each other. And this is what I refer to as hidden information. So it will never be listed, but, well, it will not most of the time it probably won't be listed, but you always know that it's true because vertical angles, we already know from previous units, are equal no matter what. So now we have got a side and then an angle squished between two sides. So side, angle, side, side, angle, side, side, angle, side. All right, next one. Here we go. Oh, here's a reflexive side right here. So in this one, should I erase that? In this one, we've got a side congruent to a different side, an angle congruent to the angle, and then boom, that second side. So we've got side, angle, side, side, angle, side. And again, this side that's shared between both of the triangles is called a reflexive side. All right, here we go. So we know that this is a line segment and this is a line segment, and normally, okay, so I know that it's 90 degrees just because I remember that picture that I had that I found online and then I cut out. I took a screenshot of it and they told me that it was 90 degrees here, but it doesn't say it. But just know that there was, oh, I don't want white, I want this one. There's a 90 degree little box in there. So a line is 180 degrees. If we've got 90 degrees here, we know that that must also be 90 degrees. And then we've got a side, an angle, and a side. The angle is between the two sides, and it matches the other triangle with a side, an angle, and then a side. And again, included angle. All right, next shortcut. this is when you don't have an angle in the middle, you've got a side in the middle. And it says that if two angles and then the included side of two triangles are congruent, then the entire two triangles are congruent. So what does it look like? Well, it looks like this. You got an angle, and then an included side, and then another angle. So if angle A equals angle D, and side AB is congruent to side DE, and angle B is congruent to angle E, then the entire triangles are congruent. Now again, let's say you didn't have that. Let's say you had that. Would that work? Yes, it would, because you've got an angle. An angle, and then a side, and then another angle. So it can be anywhere on the triangle, just know that it must be an included side. Here we go. Immediately, we're gonna mark our hidden information. We've got two arc marks there to show our vertical angles, and then we've got angle, side, angle. And again, on the other triangle, angle, side, angle. So that's angle, side, angle. Here we've got an angle, and then you go here to a side, and then you go here to an angle. And here on the other triangle, you have angle, side, angle. So the two triangles are congruent. And again, here's what it looks like. It's got an included side this time. I'm going to take this moment to talk about something really important, and it's this. The order, since the order matters, right? Like angle, side, angle is the side in the middle, side, angle, side is the angle in the middle, etc. You can, let's say, this is kind of a bad one to do it on, but let's try it. So imagine that this whole blue area is lava, and you can only stand without getting burned on either an angle arc mark or a side tick mark. Here's another angle arc mark. Here's a side tick mark. Tick mark versus arc mark. So your legs are long, however, they're not long enough to skip like really far, right? If you're trying to like jump over a cliff or whatever. And so therefore, this is just a memorization strategy to help you remember that here, if you start here and you stand here, that's fine. And then you step here, that's fine. And then you step here, that's fine. You didn't have to skip over anything. You did not have to skip over anything in order to make it all the way through. However, looking at a different one, which will be this one, angle, side, angle, postulate. If two angles and then one consecutive side of the two triangles are congruent, and consecutive means one right after the other, then the two triangles are congruent. So we look at this. Now I'm going to do the lava jump on the arc mark and tick mark thing. Here you can stand on the arc mark, and then here, see how there's no tick mark? This is what I call missing information. So there's a difference between hidden information and then missing information. The missing information is like tick marks and arc marks that are not there, and we also don't know anything that could tell us to put them there. And so since we know nothing about that side, we cannot put tick marks in there, so we have to jump over it. So I'm going to stand on the arc mark, and then I'm going to skip the side or jump, and then I'm going to stand on the arc mark, and then I'm going to go over here and I can stand on the tick mark. And I don't have to, I do not have to skip anything that time. So I stood on the arc mark and then I jumped over the missing tick mark, and then I stood on the arc mark, and then I stood on the tick mark. This is important because let's say you have this. You could stand on the arc mark, skip the tick mark, stand on the arc mark, skip the tick mark, skip the missing arc mark, and then stand on the tick mark. So this one is fine. You can skip just one piece of missing information, but this situation where you have skip, skip, not okay. You can never do that. And it's because it won't tell us when, well, I would have to show you physically, which would be an in-class thing. But either way, just know you can't have two skips. You can only ever have one skip. And that becomes important. I'm not going to show it in this video necessarily, but as we get a little bit more complex, it will be. So angle side says if angle A equals angle D and angle B equals angle E and BC equals EF, then the entire triangles are congruent. Well, let's look. So here we go. We have got a missing side information. However, it's actually not missing. It's hidden. There's a difference, remember, between hidden information and missing information. So this is a hidden reflexive side right here. Now let's look. We have got an angle. Ooh, ha. An angle, a side, an angle. But wait, it's not angle, side, angle, it's angle, angle, side. Well, yes. We can do it, oftentimes we can do it multiple different ways. So here we've got an angle, we've got to skip the tick mark, and then we've got an angle, so we've got angle, angle, and then tick mark. So angle, angle, side, angle, angle, side. AAS. That works. If you wanted to do it, if this weren't my example slide and I wanted to do it a different way, like in class or something, you could go angle, side, angle, and that would be just fine as well. Okay, ooh, this is a perfect example to show this. If you wanted to do that, start here, you go angle, skip the tick mark, skip the arc mark, and then land on the side. Not okay. You cannot, remember, have two skips. All right, let's keep going. So, no hidden information here. We have a side, angle, angle. How do you know it's a side and an angle and angle? Well, first of all, the side information has meters, and we know that angles are only measured in degrees. And also it's on the outside of the triangle. And both of these angles, first of all, they've got degree signs. Second of all, they're written on the inside of the triangle, kind of squeezed into that angle, so we know that they're angles. All right, I don't know if I did this yet. We've got, yeah, side, angle, angle, side, angle, angle. Now, it says angle, angle, side, but isn't angle, angle, side the same backwards? Yes. So SAA or AAS, doesn't matter, both work. Next, angle, skip, that's okay to skip once, angle, side, angle, angle, side. Say I wanted to start here, angle, side, skip, skip, can't do it. Say I start here, go the other way, angle, skip, angle, skip, skip, side. Ah, can't do it. Can't have two skips right there. So that's why it's important. It's not important for side, side, side. It's not important for, most people can see side, angle, side real easy. And sometimes angle, side, angle. But when it comes to angle, angle, side, that skip lava thing really becomes actually quite necessary. And if you don't know what I'm talking about, come in and see me. And if you don't know what I'm talking about and think it's dumb and not important, definitely come see me, because I guarantee you, if you don't understand and can do the realizing how many pieces of information you're skipping, you're never gonna get angle, angle, side. So next. Okay, this one is the special one because it only works for right angles. So if the hypotenuse, aka directly across from the 90-degree angles, and one leg, so the legs are both of those. It does not matter which one, either one. So if you've got the hypotenuse and then one of those legs of two right triangles, and that they are congruent, then the other two then those entire two triangles are congruent. Let's see what this looks like. So if the hypotenuse, BC, equals EF, and AB, one of the legs, equals or is congruent to DE, the other matching leg, then the entire triangle is congruent. What it looks like in person, boom. We have got a hypotenuse and a hypotenuse of the other one, and we've got one of the legs and leg of the other one, and we know it's a 90-degree. So just looking at this, we've got a hypotenuse and we've got a leg, so it's a HL, and make sure it matches over here. We got a hypotenuse and a leg. Yep, the two triangles are congruent. Oof. Now this would look like we've got a leg and we've got a 90-degree angle, but like, where's the hypotenuse? Well, directly across, it's this, but there's no information there. Is it hidden or is it missing? It's hidden because it's reflexive. Side. This AC is only ever as long as its own self. So it's as long as itself, aka it's congruent to itself. So we have the hypotenuse and the leg of this triangle, and we have the hypotenuse and the leg of that triangle. And again, this is what it looks like. Okay, and these are the ones that don't work. So angle, angle, angle will give you so many different options for triangles. It's not even necessarily going to be congruent. So this could have the same angle as this. This could have the same angle as this. And this could have the same angle as this. But their side lengths could be different lengths. And then that would obviously not make them congruent. So this produces similar triangles, not congruent. And we only care about congruent triangles because that's what we're learning about right now. Angle, side, side, or side, side, angle. Those also would produce different options for different options for what the triangle would look like. So they could be similar as well. So if you've got a angle and a side and another side, I didn't draw that very well. I'm not going to draw it. Just trust me, these ones produce triangles that look very similar oftentimes, but not the same. Not the same shape, not the same size, so therefore not congruent. All right, look for by next Sorry, I was trying to make this kind of quick. I'm sorry if I went too quick. Feel free to rewatch it, pause it, etc. I'm going to do another video on proofs because all of these are used to prove that two triangles are congruent, and I want to show you what that looks like and the reasoning and the thinking that we go through to figure that all out. So I hope that you enjoyed it. Come with questions and good luck.